I've switched on the light in the 4th session, so some progress. I keep trying to get up earlier, and eventually I will have all 4 sessions in daylight without the light. Getting there. Alright, let me talk a little bit more about this address, what's going on. Now, what we're going to do in the algorithm, we're going to systematically count up from like initially we'll fill this with 1, and then 2, and then 3, and then 4, and then these will all be blanks. So you'd have initially 1 blank, 2 blank, 3 blank, 4 blank, and all the rest blanks. And then you're systematically counting up. You're going up in numerical order. If you have letters or something, lexicographic order. But let's keep it simple with just numbers. And so you're systematically counting up. You're ratcheting up the address number systematically. So you'd start off. Look at that. So in the smallest address would be, let's just say 1, or it could be 2 or 3 or 4 in the first square here, and that would correspond to the first step in your calculation, in your tree, the 4 children of the root node. Okay, and then if you had a digit here and a digit here, and then all the rest of the blanks, that would correspond to the nodes in your second level of your tree. So, so if you're doing it systematically, you might have then a 1 here. So you could have 1, 1, 1, 1, 2, 1, 3, 1, 4, and then you're going up by numerical order, and then you could have like 2, 1, 2, 2, 2, 3, 2, 4, and then 3, 1, 3, 2, 3, 3, 3, 4, and so on. Now can you see how doing that kind of thing also ensures breadth first search? And you see how that's happening, because what is this? Like it's at each square you have the choice number, if you like. Like at each node, you may have a choice. You may have more than one child because it's non-deterministic, right? And so these numbers here, they correspond to the choice number. Now, say maximum you have little b. Say it was 4. The largest number of choices you can have at any one node is 4. So the 3 here, like for that particular node, the next node, the child node for this one, would be the third choice in your rule, right? In your transition function will return a set of tuples, and there may be several of them. So you would choose the third one. Okay, so these numbers here refer to the choice numbers at each node that's the right hand side of the transition rule given to you by the transition function. Okay, and so this all these branching numbers, if you like, so the choice number, the branching number, same thing. You start from your root node, and you're now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You're 11 layers down in the tree, and you take the first branch, and then you take the second branch of that one, the third branch of that one, and so on, until you get to a particular node at the 11th branch, 11th layer in the tree, and at each stage you can calculate. Because you're updating this the whole time. At each node, you have to look at its configuration and use the transition function, and you can find out what you have to do to your tape each time. So at each node, you're updating, you're writing on your tape and so forth. Okay. So the breadth first comes in because you're just dealing with when these are all blanks except for this one, and you go through all children at a given level, the first level. So this could systematically be 1, 2, 3, 4, and then you go through all branches of level 2. So you could have 1, 1, 1, 2, 1, 3, 1, 4, and so forth. And so by ratcheting up the address systematically, you're doing a breadth first search, okay? Because you're doing every branch to that given level. And in this case, we've got 11 levels, or 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 levels. Well, after the root node, so 12 levels in a sense. Okay, so how do we actually do it? The algorithm itself, like the stages of the computation, what happens? So in stage 1, you put the input into tape 1, and it just stays there. Right? After that, tape 1 doesn't change. And you make tapes 2 and 3 empty. So empty, empty. That's to start with. Right, now stage 2. You've copied the tape 1 into tape 2, okay? And remember, you're in a loop now where the loop is updating this address systematically, in numerical order or lexicographic order. But let's assume these symbols here are just integers, so numerical order. So you're inside a loop that's adding these up one by one. So this is the least significant digit. That's the next significant digit, and so on. So normally you'd have these reversed, if you're looking on them as numbers. The symbols you could have here are not decimal numbers, but they would be little b array numbers, where your base would be little b, not 10. Well, okay, so now what? Okay, so you've copied tape 1 into this for each loop, for each branch, for each possible address. We go through this loop. So let's say you've just freshly changed your address. So what do? Well, then you take this and you copy it into here, and then what do? Well, then you systematically go down each child, you go down each, choice, I guess, each transition. Like if you're at this node at the moment, then what will the next node be? Well, it'll be the node corresponding to the third choice coming from your transition rule. Right? Okay, so stage 3, you use tape 2. So this is now the contents of your tape. Imagining you're going down a particular branch in your tree, right? So you're updating this, writing on this all the time, and you know what to write, and that comes from the transition rule, and because at each node there is a configuration, and you use that configuration to figure out what the next configuration should be. But because it's non-determinist, you may have several configurations, future, like next configurations. But which one do you choose? Well, you choose the like if it's 3 here. Well, you choose the third choice, the third one you have in your rule, your transition rule. And if you're here, well, you choose the first one, and so on. So this. This address tape tells you which, at each node, which future, when you have a choice of future nodes or of future child nodes, which one do you choose? Well, you choose the, according to the number here at each layer. All right. So it's the same here. Like, consult the next symbol on tape 3, the next one, to determine which choice to make amongst those allowed by your transition function. The right-hand side of your transition function will give you a set of tuples, and which one do you choose to know what your next node should be, your next configuration should be. Right, now, okay, so if there are no more symbols remain on tape 3, so you get to here, so no more non-blank, right? And you get to here, then you, what do? Well, then you go to stage 4. I'll explain that in a minute. But there are various ways. Ways to get to stage 4. Another possibility is your address is the deterministic choice may be invalid. So in other words, the address is invalid. Like you might well, let's say here, you've got a 3, well, say here,